Amazon Managed Service for Apache Flink is a service that allows you to perform analysis using SQL on Kinesis data streams within real time. This lab step will use the management console to start an application in the managed service for Apache Flink. So we need to go over to Kinesis. Kinesis, not Kinesis. We should have two data streams. The first stream is an ingestion of incoming click events from a data source. The second stream will ingest sessionized Clickstream data to be consumed by the Lambda function. So we go to Manage Apache Flink. A notebook has been created. We'll use the notebook to process the click events and sessionize them using structured query language. So let's have a look. Go into the notebooks. Should have a notebook table, and then we can click on Run. We'll see a notification at the top of the page that the notebook is starting. A notebook can take up to 5 minutes to become available for use, so we'll just have to sit and wait. Right, so while that's coming up, so then we need to go back to Kinesis. Let's open both. Alright, navigate to data streams. We'll see the two streams, one for click, one for session. Go to the click stream. We'll see a series of tabs with monitored selected. View the configuration. Right, there are a few options we need to be aware of. Data stream capacity. It's the number of shards in the data stream. Each shard has a maximum read and write capacity. To increase the total capacity of data shards, you can add more shards. We've already got the one, so assuming we just leave it as it is for now. Encryption. We have encryption enabled. Okay, so now it's disabled on this one, but it can be encrypted using AWS managed or a customer managed KMS key. Data retention. This will store records for 24 hours by default. We can configure it for a maximum of 365 days. So I've just got 1 day. Enhanced shard level metric. We can add more detailed cloud watch metrics to be enabled for the data stream. Yeah, but these have extra costs, so that's why that's off. Return to the Studio Notebook. Leave this page open. We'll use it later on in the lab. So is that still going? It is. Let's see if my check works. So we've got a checkpoint. The check will start your management. So we need to see if we have started the notebooks. This probably should fail. No, it started. Okay, so again, it's probably just looking for the name, but we need to wait for it to be usable. So let's do next step. I can at least do the next bit. So previous lab, we created the data analysis application. We connect. This time we're going to connect to an EC2 instance using the instance connect. So let's do it from here. Let's go EC2. So we should have some instances. There we go. Right click on the instance. And we want to connect to it. Connect with EC2 user, make sure there's no space. Let's connect. We can also connect an instance from SSH, which I'm not going to do. Right, simulating a real-time clickstream. In this step, we'll use the shell that we accessed in the previous step to simulate the clickstream. You need to create a template JSON for a click event. Okay, I see what it's doing. So it's just going to literally echo out an example feed into the click.json file. So you've got click.json now. Right, the template will contain 5 fields: event type, device type. They're all hard-coded. You may encounter streams from different events. But yeah, that's not for this. So right, to put records into Kinesis and simulate a click stream, we have to enter the following. So this will adds a variable, some users, the events, and then for every, well, for 5,000 iterations, it's going to create some random data. There we go. So each time this iterates, it's just going to do that. So 2-second interval between each event. After 60 minutes, oh no, after every 60 events, there's a 15-second interval, so it gives us a good lag between chunks of clicks. So that's fine, we can ignore that. Right, return to your Studio Notebook page. Right, this is actually working now, so we can do that. So let's open it in Apache Zeppelin. Apache Zeppelin is a web-based notebook for developing event-driven analytics. It supports many languages including SQL, Python, Scala, and R. Alright, so we are going to do, let's go create new note. And we're going to call it lab. Let's create. Kind of like Jupyter notebooks by the looks of it. So, blinking cursor inside the paragraph is typically comprised of many paragraphs that subsequently accomplish a given task. To create a table for the Kinesis stream, enter the following. So we have to do this. So this is checking if the table exists. If it does, create the table. Create 2 tables, one for the click stream, one for a session stream. First line is a directive that specifies that you want the paragraph to be interpreted using Apache Flink. And then the with clause. There is an IAM role that has permission to send and receive data from this data streams. Right, so we can now run that. Should take a little while. Should take 30 seconds, so let's see. Waiting for this running to change to a finished, so there we go. Right, so now we can, to view the data from the stream in the new paragraph, we can enter this. I didn't like that, probably because got to edit this one. Already got the Flink, so let's just do that. Yeah, that's better. There we go, so we've got a table, should show some content. Oh, it's actually a note, don't double up the first directive line yet. Yeah, we found that one out. Hence the big red box. Right, this will take 10 to 20 seconds, you'll see a table appear with the results. There we go. This is data that's being put into the Clickstream Kinesis data by the bash code that we ran earlier. To stop the query from running, we have to stop this one. So let's cancel. Because this is live, it's just going to keep adding. Right. This lab is dealing with a small stream of data for the sake of convenience. The notebook has been provisioned at a low capacity, so you can't. If you don't cancel a running query, you may see errors about usage. In this lab step, you ran a command. Yeah, cool. Right, so we have to check if we ran the console command to generate the event. So let's prove I did that. I did. Right, and then Flink will also allow you to continuously run SQL on streaming data. It will process it in real time, send results to many different destinations. So in this step we're going to use SQL to determine the beginning of a new session in this Clickstream. So to identify events that start in a new session, we'll use this notebook paragraph. So we've got a new SQL. Let's run that. This again will take a minute to see the records, but you will see records that are displayed in the table with a new column named New Session. So there's a new column. See on this. So we've got a new session column. This query uses the lag SQL function to compare a record with the previous record. So there, so we're doing that. The petition by user ID clause means it restricts comparisons to records whether the user ID is the same. Then order by looks at event time. When there's a difference between the event stamp and two records greater than 10 seconds, a new session field will be 1. This denotes the start of a new session. When a new session is 0, it denotes the event of a continued session. Comparison multiplies 10 by 1000. This is because event stamp is in a Unix time. Stop the previous query by pressing the pause icon. Again, we're doing this on the cheap. To only get the new session boundaries in a paragraph, we'll use this query. Wait. This will take a minute. The statement contains the previous statement in a subquery. So this time the outer query selects all the fields and constructs a new field named Session ID. Session ID is made up of the user ID joined with a summation count of the session boundary. This will produce a session identifier that is unique within this query execution. Outer query also has a where clause that filters the results of the record where the new session is won. In a non-lab environment, you might want to construct a session identifier using more data to uniquely identify the session, such as the server or the instance. Typically, a large distribution system can come from disparate sources, usually a universally unique identifier. Right, there we go. So now we're getting session IDs of the user and the number of sessions that they've had. We can actually stop that.
215 raiders from TRSH Puppy have
Jesus
joined.
H Christ! Thank
Coder
you for the
says.
raid, Trash Puppy.
TrishBW.
Yo 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 yo!
Trash Puppy.
No, I'm
The
just
puppy
dumb.
who roots through your trash.
I don't know
says.
when you guys are gonna get it.
Yo yo
Through
yo
your
yo
thick
yo.
Come
skull.
away.
That I'm
Translated
thick.
from Vietnamese.
Like dumb.
Coder says.
Thick.
Oh,
Not
only
dummy
what's in your
thick.
channel.
Just
No
dumb.
last name
thick.
says. Son.
With a K. And
Translated
not
from
two
Spanish.
C's.
Roadblock 93 says.
Okay.
Raid. Trash Puppy.
It's a good
The
clip.
puppy who roots through your trash says.
Word R. I'm gonna
You are.
double down on this though. We're still
That's a
gonna.
good clip for this, haha. How you do that?
Cypher Enigma
I've
says.
got like an
Vintage
add-on,
clip.
so there's like a browser plugin you set up, and it detects when raids come in, and it will just go off and pick one of your clips randomly and play them. I'll send it to you, so if you want to copy it. Yeah, we're just going through an
Trash
AWS
Puppy.
lab at the
The
moment.
puppy who roots through your trash says.
That's awesome, lol.
NSA Van 42069 says. We'll just park here for a while. Don't mind us.
No worries. Right, I'll probably turn off TTS for a sec.
Tra-
Otherwise, I'll just hear that. Yeah, so we're going through an AWS training lab. Basically, we've created well, no, we haven't created. There's a Kinesis stream. So Kinesis in Amazon is like a feed of data, and we're simulating a feed using this connection. So there's some code running that's just making this like random data, sticking it in the Kinesis stream, and then we're using this notebook to basically query that data as it's in the stream. And then yeah, so we're just basically running queries that this lab is giving to me. So I'm not doing anything fancy, I'm not writing any of it myself. But it's just to give a feel of like how you would use it. But essentially it's this, so we're just looking at what the data is. So far I've run, I'll give you a heads up of what I did already. So run this, creates the tables, and then this was me fucking it up. And then this one just selects the data, so you'll see like user IDs, like this is just the random stuff that we made. Then we've got some other query that's looking at the difference between timestamps and trying to detect users changing, so we could determine sessions. And then this one is looking at specific users and trying to dive into like the user and the number of sessions that it had open. And then this next one is doing something else which I haven't read yet, so I'll tell you when I get to it. So this one's going to look at inserting records into the session stream. Let's have a look. I have no idea what this does. So hopefully this runs. It's kind of like Jupyter Notebooks, if you've seen that before. So we'll take that top line out. There we go. So this query is going to wrap the previous query in an insert statement. It then puts records into the session stream table. Because the query produces no output and it's expected to be long running, you'll see the duration displayed at the bottom of the paragraph. There we go. Right, this could take up to a minute for the duration to display. Now we've got an ad running. Don't get mad at me for doing this, just testing stuff on your channel. No worries. Yeah, feel free. Usually, I don't know if you can hear me because there's an ad running, but I do have a bot. So if I do any Try Hack Me content, I run a bot in the background. So there's redemptions that will just kick me out of the box. So basically, if I've got like a reverse shell running and I'm attacking that machine, you do that and I'm just no longer. I'm not on the box anymore. I have to like regain my foothold and attack it again. From scratch. Right. So you're now sessionizing the Clickstream events into session events. We have to leave this query running, later lab steps depend on it, so we can feel free to open a new paragraph and issue the following command to view view records in the session stream. So we leave this running. And then this will give us, this keeps running too, doesn't it? So this should give us the data that we've got. So this lab, we used the notebook to mimic the process for developing an analytics application. So we didn't need to create an app, we're just using this notebook to do it. It's out of scope for the lab, but be aware that you have developed your app. Kinesis will support deploying it in a more durable fashion. If you performed a type of data aggregation, use the notebook, process records from source stream. Using the Apache Flink can be customized into a Java jar file you provide for yourself. This means that the Java code could load or deliver data from any network accessible system. Okay, fantastic. Right, so let's see if I did my check right. We should have a... So we've got a validation step. So did I do it right? I did! Right, cool. What's next? So, storing sessions in Amazon DynamoDB table with AWS Lambda. Right, so Lambda is a way of running code without having to provision any servers. It's a serverless implementation on AWS. We're going to create a function that will process the clickstream data that we've sessionized. So we need to go, let's do it from, let's use that one. Right, Lambda, we've got a function already, nice. So click on the function named lab. This function resource was created for you. We have to scroll down to the code and change it. So this is the default. I'm going to replace that with this. So goodbye Lambda function, hello new Lambda function, and deploy. Right, that's updated. We need to add a trigger. Where's that? Function. Ah, there we go. Add a trigger. Right, the trigger is going to be Kinesis. And then we want the stream as session stream. Don't need anything else. Leave all the other things default. Nice, so we can ignore all that. Add. So now, whenever this Kinesis event comes in, it's going to run this function. We also need. Where have we got that? Dynamo. Should explore items. Right, so we've got a DynamoDB table. So DynamoDB is like a non-relational database, so it's we should be able to show you the items. So yeah, so do that into. So that we should see something. There we go, got something now. Right, yeah, if you don't see any items, wait a minute, you have to, obviously the Lambda function has to have actually consumed data from the stream. But yeah, so now this feed of data, when that feed comes in, it's running, let's go back, this code. So this code is using the Boto3 client for DynamoDB to add a new item into the DynamoDB, and then DynamoDB is literally showing you the records that we're creating. So let's have a look. So yeah, another validation. Check that the items are added to the table. They obviously were, because we can see them anyway. And that is apparently it. That's the lab done. So I can actually close that down. Usually it makes me like delete all the like artifacts that it's built, but obviously it's not doing that this time. So I'm going to let them shut all that crap down. Right, so it's